There is no national electrical code requirement mandating the connection of a number 10 copper wire to a 20 amp breaker. However, a number 12 copper wire can be used on a 20 amp circuit under specific conditions. This is where the application of 240.4 D of the National Electrical Code, NEC, becomes crucial. 240.4 D addresses the protection of conductors against overcurrent. This section outlines specific circumstances where the standard overcurrent protection rules are modified for certain conductor applications. 240.4 D provides exceptions to the general rule that conductors must be protected at their ampacity. The ampacity of a conductor is the maximum current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. NEC Table 310.15 B16 provides ampacity ratings for various conductor sizes and insulation types. A number 12 copper conductor with type THHN insulation typically has an ampacity of 20 amps. However, without the exceptions provided in 240.4 D, this conductor would generally need to be protected by a 20 amp overcurrent device. The exceptions listed under 240.4 D include specific installations such as motor circuits, control circuits, and certain appliance circuits where smaller conductors are permitted to be protected by larger overcurrent devices. These exceptions acknowledge that in certain applications the risk of overload is minimal and the conductor is adequately protected by the characteristics of the connected equipment. One of the most common applications of 240.4 D is in motor circuit. Motors often have high inrush currents during startup, which can briefly exceed the ampacity of the conductors. To prevent nuisance tripping of the overcurrent device, the NEC permits the use of larger breakers or fuses that can withstand the inrush current without damaging the motor or the conductors. The specific requirements for motor circuit protection are detailed in NEC Article 430. Article 430 provides detailed guidance on selecting the appropriate conductor size, overcurrent protection, and control equipment for motor circuits. It includes tables and calculations to determine the maximum allowable overcurrent device size based on the motor's full load current and other factors. It is important to note that the exceptions in 240.4 D are not universally applicable. They apply only to the specific types of installations listed in a section. In general, conductors must be protected at their ampacity, as specified in NEC Table 310.15 B16 unless an exception applies. For example, a number 14 copper conductor with type THHN insulation typically has an ampacity of 15 amps. Without an exception, this conductor must be protected by a 15 amp overcurrent device. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. An overload occurs when the current in a circuit exceeds the ampacity of the conductors, but the circuit is not shorted. A short circuit occurs when there is a low resistance path between two conductors, causing a very high current to flow. Overcurrent devices interrupt the flow of current when an overload or short circuit occurs, preventing the conductors from overheating and potentially causing a fire. The selection of the correct overcurrent device size is crucial for electrical safety. If the overcurrent device is too small, it will trip unnecessarily, causing inconvenience. If the overcurrent device is too large, it will not protect the conductors from overloads, potentially leading to overheating and fire. When selecting an overcurrent device, it is important to consider the ampacity of the conductors, the characteristics of the connected equipment, and any applicable exceptions in the NEC. In addition to 240.4, the other sections of the NEC also address conductor protection and overcurrent device selection. For example, Article 310 provides detailed requirements for conductor ampacity, including dirting factors for ambient temperature and the number of conductors in a raceway. Article 240 provides general requirements for overcurrent protection, including the types of overcurrent devices permitted, the interrupting rating of overcurrent devices, and the location of overcurrent devices. The NEC is a comprehensive set of rules and regulations designed to ensure electrical safety. It is essential for electricians, electrical engineers, and other electrical professionals to have a thorough understanding of the NEC to design and install electrical systems that are safe and compliant. In summary, while a number 10 copper wire is not required for a 20-amp breaker, a number 12 copper wire can be used on a 20-amp circuit if the installation meets the requirements of 240.4 D or other applicable exceptions in the NEC. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidance. Always consult with a qualified electrician for any electrical work to ensure safety and code compliance. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is important to stay up to date with the latest edition of the NEC to ensure that electrical installations are safe and compliant. Many jurisdictions also have local electrical codes that supplement or amend the NEC. It is important to be familiar with the local electrical codes in your area to ensure compliance. Electrical safety is paramount. Always take precautions when working with electricity, and always consult with a qualified electrician if you are unsure about any aspect of electrical work. Remember, electricity can be dangerous, and it is important to treat it with respect. Firstly, always turn off the power at the breaker before working on any electrical circuits. Secondly, use insulated tools to prevent electric shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on electrical circuits when you are wet or standing in water. Fifthly, if you are not comfortable working on electrical circuits, always call a qualified electrician. Understanding the NEC is critical for safe electrical practices. The code provides specific guidelines for wire sizing, overcurrent protection, grounding, and many other aspects of electrical installations. By following the NEC, electricians and other electrical professionals can ensure that electrical systems are safe and reliable. Continuous education is also essential in the electrical field. New technologies and materials are constantly being developed, and it is important to stay up to date with the latest advancements. Many organizations offer training courses and certifications for electricians and other electrical professionals. These courses can help you expand your knowledge and skills and stay current with the latest industry standards. Safety inspections are also an important part of maintaining electrical safety. Regular inspections can help identify potential hazards and ensure that electrical systems are in good working order. Many jurisdictions require electrical inspections for new construction and renovations. It is important to comply with these requirements to ensure that your electrical system is safe and code compliant. Grounding is another critical aspect of electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the overcurrent device and prevent electric shock. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metal parts. Proper grounding is essential for protecting people and equipment from electrical hazards. Bonding is another important aspect of electrical safety. Bonding is the process of connecting metal parts together to create a low impedance path for fault current. Bonding helps to equalize the voltage between metal parts, which reduces the risk of electric shock. The NEC provides detailed requirements for bonding metal parts in electrical systems, including the size and type of bonding conductors and the methods for connecting them. Surge protection is also an important consideration for electrical safety. Surges are brief, high-voltage spikes that can damage electronic equipment. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors are devices that are designed to protect electronic equipment from surges. Surge protectors typically have a metal oxide varstor, MOF, that diverts the surge current to ground. The NEC requires surge protection in certain applications, such as dwelling units and critical facilities. Arc fault circuit interrupters, FSIs, are another important safety device. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when insulation on wires becomes damaged or when connections become loose. GFCI strip the circuit when an arc fault is detected, preventing the arc from starting a fire. The NEC requires GFCIs in many branch circuits in dwelling units, such as bedroom circuits and living room circuits. Ground fault circuit interrupters, GFCIs, are another important safety device. GFCIs are designed to detect ground faults, which occur when current leaks to ground. Ground faults can be caused by damage to insulation or faulty equipment. GFCIs strip the circuit when a ground fault is detected, preventing electric shock. The NEC requires GFCIs in many locations, such as bathrooms, kitchens, and outdoor areas. The NEC also provides requirements for wiring methods. Wiring methods are the ways in which conductors are installed and protected. Common wiring methods include conduit, cable, and surface raceway. The NEC specifies the types of wiring methods that are permitted in different locations and the requirements for installing them. The NEC also provides requirements for electrical equipment. Electrical equipment includes items such as panel boards, transformers, and motors. The NEC specifies the requirements for the design, installation, and maintenance of electrical equipment. Proper maintenance is also essential for electrical safety. Regular maintenance can help identify potential problems and prevent electrical hazards. Maintenance tasks can include checking connections, inspecting wiring, and testing safety devices. It is important to follow the manufacturer's recommendations for maintaining electrical equipment. Electrical safety is a shared responsibility. Everyone who works with electricity should be aware of the hazards and take precautions to prevent accidents. By following the NEC and practicing safe work habits, we can all help to create a safer electrical environment. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work to ensure safety and code compliance. The NEC is a complex document, and it is important to have a thorough understanding of its requirements before attempting any electrical work. Many resources are available to help you learn about the NEC, including training courses, books, and online resources. By investing in your education, you can improve your knowledge and skills and become a more competent and safer electrical professional. Always remember that electrical safety is the top priority. Take the time to learn about the hazards and take precautions to prevent accidents. By working together, we can all help to create a safer electrical environment for ourselves and others. Understanding these codes and regulations is a must to prevent electrical-related accidents.